class. In today's lesson, we'll see differentiation from first principles. There are two basic ways you can perform differentiation. Either you are using the first principle or you are using the formula. The formula tells us that if I have y is equals to ax raised to power n, then I'll be saying that my dy dx will be the same thing as anx raised to power n minus 1, where a is my coefficient and n is the power of x. But today we'll be seeing from first principle. That said, let's get into class. Let's use this example. My example says that if I have y to be equals to x squared, now we are differentiating from first principle. So that if y is equals to x squared, I'll call this my equation 1. From 1, I can increase my y, which will also result to an increase in x. So that I'm saying that my y now plus a change in y will be equals to my x plus a change in x. But remember that the x is squared, so my change in x also will be squared. So that my y plus delta y now will now be equals to, let's open this bracket, x plus delta x into x now plus delta x. So that this is the same thing as, if I open this bracket, it becomes x into x plus delta x plus delta x now into x plus delta x. So that this is the same thing as x squared plus x delta x plus x delta x plus delta x all squared. So that this is the same thing as x squared plus 2x delta x plus delta x all squared. Now this is y plus delta y. Let's call this equation my equation 2. Now what I want to do next is I want to subtract equation 1 from 2. So that I'll be having y plus delta y minus y will be the same thing as x squared plus 2x delta x plus delta x all squared minus x squared. Now y minus delta y plus delta y minus y, this gives way. My x squared minus x squared, this gives way. So that I'm left with delta y now to be equals to 2x delta x plus delta x all squared. First principle tells us that at this stage, I'm going to divide through by delta x. So that delta y over delta x now is the same thing as 2x delta x plus delta x all squared divided by delta x. This cancels this. So that delta y over delta x is the same thing as 2x. This cancels one of delta x also, so that is plus delta x. Now, as delta x tends to 0, first principle tells us that delta y over delta x tends to dy dx. Obviously, my dy dx will now become, here I have 2x plus delta x. Delta x obviously is going to tend to 0, it's going to become 0, and I have just 2x left. dy dx is equals to 2x. Now let's verify this from the formula. The formula tells us that if I have my y to be equals to ax raised to power n, where a is a coefficient and n is the power of x, my dy dx will be equals to anx raised to power n minus 1. Now from our example tells us that we have y is equals to x squared. Now y here is equals to x squared. So that my dy dx in this case, that my a in this case is the same thing as 1, and my n is the same thing as what? 2. Will be equals to, dy dx will be equals to a is 1, times n is 2 times x now raised to power 2 minus 1. That will be equals to 1 times 2, that's 2, that will equals to 2x raised to power 1, that's 2x. And you can see we got the same thing from first principle. Now let's take another example. Now this example says I have y is equals to 2x squared plus 5. Now I'm to find the dy dx. Now, like we did the other time, my first principle, I'll be increasing y so that y plus a change in y will be equals to 2 into x plus a change in x all squared plus 5. So that y plus a change in y will be the same thing as 2 into, if I expand this like I did the other time, you agree with me that this will become x squared plus 2x delta x plus delta x all squared plus 5. Now, so that y plus my change in y will be the same thing as 2x squared plus 4x delta x plus 2 delta x all squared plus 5. Now let's subtract. Let's call this our equation 1, like we did the other time. Let's call this our equation. If I'm subtracting equation 1 from 2, obviously my y plus delta y will subtract y. I'll be left with delta y to be equals to my 2x squared for clarity's sake plus 4x delta x plus 2 delta x all squared plus 5 now minus 2x squared plus 5. If I open this bracket, this will become 2x squared plus 4x delta x plus 2 into delta x squared plus 5 minus 2x squared minus 5. I have minus 2x squared plus 2x squared, it becomes 0, plus 5 minus 5, it gives way. So that's delta y now, I'm left with 4x delta x plus 2 delta x all squared. The next thing we'll be doing, we'll be dividing through by delta x. So that by delta x, not delta y, by delta x. So that delta y over delta x will be the same thing as 4x, I've divided that by delta x plus 2 delta x. Now, as delta x tends to 0, you agree with me that delta y over delta x begin to tend to dy dx. So that dy dx finally will be the same thing as 4x. Here I have 4x. Because I have delta x here, it becomes 0. So the whole of the 2 also becomes what? 0. Now let's use our formula method to test our answer. Y is equals to 2x squared plus 5. I want you to note how I will treat 5 because 5 is a constant. I'll treat it this way. Y will be equals to 2x squared plus 5x raised to power 0. X raised to power 0 is the same thing as 1. 1 times 5 is still 5. So I've not changed that equation. So that if y is equals to ax raised to power n, my dy dx will obviously be equals to anx raised to power n minus 1. So that my dy dx in our instance will be equals to, I have 2. 2 is my a times n. That's 4 x raised to power n minus 1. That's 1 plus 5 times 0 x raised to power 0 minus 1. Obviously, everything here becomes what? 0. So I can do away with it. So that my dy dx will be the same thing as 4x. You see that same thing as we got from first principle, we have using the formula. This I hope you understand how to differentiate from first principle. Thank you for staying with us and see you in our next class.